Hello and welcome to another IoT Central webinar. I'm David O'Hara and I'm the Managing Director at IoT Central. I'd like to start by thanking SECO for sponsoring today's event. The title of today's webinar is Clea, the industrial end-to-end IoT solution to orchestrate devices, data, and advanced AI applications. Now, I'd like to introduce today's speaker. Marco Soi is the head of global software at SECO. Marco, when you're ready, let's get started.
Thank you, David. I'm glad to be here on IoT Central. And today I'm here to present Clea. Clea is our end-to-end IoT solution to orchestrate devices, data, and advanced AI application. SECO today is a group specialized in the design and production of advanced technology solutions for the Internet of Things and embedded computing. Today, we are providing integrated hardware, software, and services for many different sectors, such as healthcare, industry, automation, and wellness. Today, our three main pillars of technology are Edge, IoT, and AI. Edge offering is composed by our device catalog. IoT, for us, are the components that interact with hardware devices on the field from a cloud software infrastructure. And AI are the algorithms and models that we can use to get out the most from the data collected from the edge devices. In terms of edge solutions, SECO offers a range of edge computing systems and HMI solution designed for various applications. In particular, we have custom edge solution, so products meet specific customer requirements, HMI, so edge devices with integrated panel technology, modules and single board computers that is still part of our off-the-shelf product catalog, fanless embedded computer that are our box solution, payment systems and IoT telemetry is a cashless payment module with included telemetry capabilities, offering a secure and efficient solution for payment and remote monitoring. And this is just to introduce to all the people here in terms of edge devices what SECO do. Clea is our software suite, and in this webinar, I would like to cover the importance of Clea, so our industrial end-to-end solution, and how much this is essential for supporting customers, clients in managing the entire life cycle of their deployed products. So we do this by integrating data orchestration, device management, and advanced AI application. And these platforms can empower businesses to monitor, analyze, and optimize product performance in real time. So this capability not only improves operational efficiency, but also enables predictive maintenance and faster adaptation to ever-changing market needs, ensuring that our products remain competitive and effective throughout the whole life cycle. I say Clea today is a software stack composed of four main components. The main components are highlighted here in this slide, where you can see our Clea platform and all the four components. In particular, from a very high-level perspective, Clea Portal is a web-based front-end, providing a user-friendly interface for managing accesses, monitoring data, and running real-time web application. And it includes reporting tools to generate insight and track performance metrics. And in the middle, in green, you can see Clea Astarte. Clea Astarte is a platform layer focused on data orchestration and modeling. This layer facilitates edge-to-cloud communication and offers different SDKs, so software development kits, for integration with various devices and software environments using APIs. In blue, here you can see Clea Hedgehog. So this module allows remote device management, updates and container orchestration at device level, but also on a fleet basis. And this is the great added value of this component. And then in black on the right, you can see Clea OS. Clea OS is an industrial Linux operating system tailored for IoT applications that natively integrates all the features and components required to enable Clea Software Suite on CPU-based edge devices designed not only by SECO. So going in details of the four components, we will start with Clea Portal. Clea Portal, as said, is an extensible IoT front-end that enables different services. Clea Portal has all the base features expected of a web-based IoT front-end, and these include user access, device and data visualization and reporting, and also permission control. Clea Portal's application framework allows developers to extend the front-end with custom web application that can interact with edge devices through Clea Starte and Clea Jog APIs. Clea Portal enables selective deployment of different extensions or Clea Jog application to user and integrate also some building framework that allows to manage a subscription model for application and edge device. Clea Starte is the component designed to facilitate the data exchange between connected devices and the cloud. This provides a flexible and scalable solution for orchestrating data coming from the devices, and this is foundation data source for the Clea Portal web application. Clea Starte is designed to simplify the integration and the handling of complex data in industrial IoT environments, taking care of connection losses, as an example, reduced bandwidth, while keeping the security and scalability our top priorities. Starte, great added value is the fact that it supports a wide range of software development kits for many different programming languages, making it ideal for the integration in almost all the software environment in terms of operating system that we can find in the industrial market, but also on different hardware architecture, both from CPU to low power MCU. Going deeply on Clea Jog. Clea Jog is a key component of Clea, and it has been designed in order to allow for efficient and scalable device management. And this allows secure updates on the field, and the main feature of Clea Jog are remote device management. Remote device management allows for monitoring device status and remote secure port forwarding. This is used to remotely connect to the device even behind firewall. Remote update. This feature in particular allows over-the-air updates on edge devices, simplifying the deployment of patches, new features, or bug fixes across a fleet of remote devices. Another particular feature of Clea Jog is that it supports fine-grained campaigns. This means that this enables users to roll out updates to specific devices or group based on specific criteria like type, location, or current software version. This is super important in industrial environment because it can minimize the disruption and ensuring that updates are delivered to the right devices at the right timing. And one of the most important features of Clea Jog is the containerized application management. With these specific features, it is possible to orchestrate updates not just for the operating system, but also at application level. And this makes it simple to deploy and easier to deploy, update, and scale application independently one from the other, again, on per device based or group based. The last component of Clea is our operating system. Clea OS is a Linux operating system framework designed specifically for the industrial embedded devices. So this is built on top of the open source Yocto project, and it offers a flexible and customizable platform that can be tailored to meet the specific need of various hardware architecture and applications. CleaOS by design supports multiple architecture and we are going from low power ARM devices up to server grade x86 CPUs, and we have no lock-in here, given it can run not just on SECO design but also on hardware not produced by SECO. So CleaOS is an important component of the Clea software stack, because these components allows an out-of-the-box connection to the Clea IoT technology stack and enables the possibility to manage the device remotely, ensuring secure remote over-the-air updates, device monitoring, and remote access, no matter the hardware architecture, allowing Clea to be deployed not only on SECO edge devices, but also on Raspberry Pi, emulated environment like QEMU, and silicon vendors evaluation kit like we are doing for NXP. So after having presented all the components of Clea, I would like to share here an architectural overview of our software stack. So from an high-level architectural perspective, the four components are interconnected each other, as you see here in the slide. So CleaOS is the base layer, and through the device runtime of Hedgehog, it is able to communicate with the Clea infrastructure using a Astarte message hub, which is a core component of Astarte that allows different software actors to send and receive data data to and from Astarte. Clea Astarte is the middleware of our software stack, and it's where all the data orchestration related business logic is performed, as well as where all security mechanisms for pairing devices and communicating with other cloud systems via APIs is possible. And in this using API, it is also possible to integrate our solution with third parts environment. Clea Hedgehog, as you can see, allows direct connection to the edge device for the port forwarding feature. In this case, we can directly connect to the specific devices, the specific device also behind firewalling, but it is also tightly coupled with Astarte that is used as data channel tunnel for exchanging data with the platform. So Clea Portal include a back office for creating organization, managing user accesses for our customers, but it includes also the possibility to extend the architecture by the development of custom portal applications. So those portal applications are easy to develop and allow to create different real-time views on Astarte data, as well as allowing for custom interaction from the cloud down to the edge devices. This is the killer feature of our software stack, given that it is ideal to extend and enhance the user experience of all of our customers for different market segments with a tailor-made UI and UX approach. With this slide, I want to highlight also an important added value of our Clea software stack. So the fact that it is extremely flexible, and this allows many different deployment scenarios on both sides of the table, on the edge and on the cloud. So for the cloud part, the technology foundation are based on Kubernetes, and this make this product ideal for software as a services offering, but also for on-prem deployment. And the fact, from an edge perspective, there are virtually no limitation. As you can see here, our edge offering is based on Clea OS, but there are virtually no limitation because this platform is ideal for all those customers experiencing a fragmented edge installation base, but especially for system integrators that could reuse Clea on many different environments, closing what we call the last mile gap, so the edge layer, where SECO is running its business since more than 40 years now. In this webinar, I would like to focus on a specific use case of Clea. So after giving you an introduction on what Clea is, what the components are, I would like to focus on how Clea could be used in a real use case scenario, listing requirements that we see every day from our customers. So in this case, we have a company, Acme Corp. So that is a global company delivering 100,000 of industrial devices per year across the globe. So this company have a fragmented edge offering in order to meet a fragmented demand, and they are well renewed for their assistance and for keeping the pace of the tech evolution while keeping the device secure. So the requirement that we have from this customer are that they are working with an heterogeneous edge devices, so they have ARM, x86, but also MCU-based edge devices. They have different customer base, so each customer wants to receive a customized web application and customized services. They want to offer real-time actionable data, so in order to get insight from the field, to perform forecasting on downtimes. So they also have a global service team, and on a global base, they want to offer the best service team experience. Security is a top priority, and they want to also run AI on the edge, while offering long-term support for the devices that they are selling to their end customer. So starting from the first requirement, so heterogeneous edge devices, the main components that we can use from our Clea stack is our Clea OS, but also the defined SDKs. With this requirement in particular, Clea OS today supports NXP, MediaTek, Qualcomm, Rockchip, AMD, but also Intel, and it allows to develop an hardware agnostic environment and target the build for any given hardware architecture, and it natively integrates all the necessary Clea components without requiring any integration effort for our customers. A starter device SDK, again, can be used to run, to get data from devices and perform OTA on devices, managing a wide range of MCU, given that the Zephyr SDK and community is always more expanding. In particular, the Clea OS architecture, that is the main focus today of Clea, for the operating system part. Here you can see an architecture. It is composed by many different layers. It is based on Yocto, and it can run on many different hardware architecture, but also on non-SECO hardware. As you can see, it is supporting also Raspberry Pi. And this kind of OS framework allows for easy customization for our customer. Going to the second requirement, so our customer has a differentiated customer base. So each customer receives a set of custom edge and web management application with customized services. So in this case, we can again use the same edge component, but on top of that, we are adding Clea Portal and Clea Start. So in this case, Clea Portal allows the user to create different realms, one for each customer, and each customer and each customer can do that for their end customer. So this allows a differentiated experience based on the same data orchestrated by Clea Starte. And again, we can allow a fine-grained user permission management using Clea Portal. In this slide here, you can see a screenshot of the back office of a sample of of Clea Portal. And here you can see how it is possible to create different organizations. Another requirement that we always see from the market is to get real-time actionable data. So we want to get real-time data for forecasting downtimes and environmental changes. In this case, Clea Starte is based on data model definition that defines interfaces. So the interfaces are common to and known to the edge and also to the portal part of Clea, and vice versa. So each portal web application is built on top of a set of interfaces, and every time a device is using a superset of those interfaces, the web application is available for such specific device. So in this case, we can get web application based on specific interfaces, and we can see this web application from each device that is able to export a specific interface. As you can see here, we have a screenshot of our Clea portal. We can see different appliances here, so we can have like a people counter or a temperature and humidity brightness device here. And here you can see an example web application showing real-time data. Real-time data are those shown in on the top, while the graph is showing the historic series of data, and in blue a forecasting on how the temperature could change in the future. So here the most important message I want to give is that with Clea portal application, you can show real-time data, you can show time series data, but you can also use AI application in order to forecast some measurement, or this specific use case could be used also for predictive maintenance algorithm. Another important aspect that we are always asked to help with our customer base in industrial environment is that the challenge that they experience when they are selling product globally. So, and they want to offer the best service team experience on a global scale. So we can use in this specific use case, we can take out the most of those components of Clea. In particular, through the Clea portal, we can create custom web application in order to help a global service team with updated manuals, live insight from the device, and also help doing advanced troubleshooting, while the headquarter operators can see and interact with the device and the operator in real time, also taking full control of the machine with the remote terminal using Clea Hedgehog. Here, I just wanted to show a sample Clea portal application where we can see that our service team of our customer can be helped through a troubleshooting guide, and it can be guided with a step-by-step tutorial helping in the troubleshooting with the help of the headquarter, all looking at the same data and all being connected to the same device. One locally, so the service team, and the headquarter from remote. Security, again, is quite a challenging aspect today because we want to deploy a secure system, but also to maintain a secure fleet. So with this specific requirement, CleaOS and CleaJog could help our customer because CleaOS and CleaJog together allow to create a separation between the operating system and the business logic of each market through a modern microservices architecture on the edge. So CleaOS is secured before the deploy and is continuously controlled offline for its vulnerability, as well as the container vulnerabilities that can run on top of CleaOS. And using CleaJog, we can easily deploy operating system update, but not only, we can also orchestrate the container update on our devices, allowing for a fine-grained update in case some security features must be updated after the deployment on the field. AI on the edge, we briefly touched this. So once we develop an AI algorithm on the edge, we expect that this kind of algorithm could become better and better during the time and during the product life cycle. So we want to be able to retrain and want that our customers are able to retrain and to deliver improved version of the same algorithm over the time. So in this case, we can use CleaOS in order to allow us to execute native accelerated AI algorithm targeting different silicon vendor architecture. So data from the AI algorithm could be used, could be sent through Clea started, and again, Clea started data could be used to retrain the model. And we can use CleaJog to orchestrate the containerized AI application, and we can update the AI application on a device base or on a fleet base. And then, of course, almost all of our customers, industrial customer, I mean, when they ship something on the field, we are talking about industrial environment. They want to offer long-term support. So in order to offer long-term support, it's important to offer long-term update services. And again, here, CleaOS, Clea Started, CleaJog together could offer a way to receive update and security patch for the operating system layer. We can use Clea Start in order to collect data about the health status of a machine, and this could also help avoiding downtimes and also help in predictive maintenance. And CleaJog orchestrates the OS and application secured update. So we can deploy new features, security patches, and fix bugs once the product are deployed on the field. So with this webinar, I just wanted to pass the message on how Clea, our industrial software end-to-end solution, creates value, supporting customers in managing their deployed products at all levels of the business. So Edge, IoT, and AI. Not only deploying cutting-edge technology, but also keeping this technology relevant for the whole life cycle of the product. So thank you all for joining this webinar, and see you next time. So David, thank you.
This brings our webinar to a close. I'd like to thank Marco for his presentation, and thank you to SECO for sponsoring today's event. You can view more webinars at iotcentral.io. Thank you for watching.